I have always loved this conference, and it's a huge honor to be here today. We've spent the last year and change at Tinder working on sort of cleaning up a code base that was never genuinely prepared to be as successful as it was. And it's a legacy code base. So we have a lot of code that works correctly and is really difficult to work on, so it's difficult to change. And we've heard a lot of talks about this today. I think it's because it's such a common, recurring theme in the work that we do. And Swift was an incredible opportunity, served as a catalyst, I think, for sort of rebuilding and improving our app architecture. And when we started to look at how we could achieve this, one thing we kind of ruled out, because I know it's really tempting to rewrite the whole thing. Tinder seems like a very simple application. It's actually pretty complex internally. There's a lot going on. Part of the reason is that, excuse me, very few screens, a lot of features. So first thing I want to mention is some bad advice. So don't do this, right? We don't want to jump in and say, okay, we're going to rewrite this in Swift. So start rewriting it in Swift. I think it was really helpful to take some time and really talk about how we wanted to approach it. And this is a quote that's floated around for essentially as long as I've been thinking about programming. It's a great quote. What sucks about it is actually true, but obviously we don't want to take that advice. But there's a lot we have to think about. We're putting together these apps that host an incredible amount of complexity in very little sort of real estate. And I think the very natural inclination is to do, I'm going to call it, I've heard it referred to as functional decomposition. This is different from functional programming. It's actually kind of a bad thing. And this bad thing is, because I have networking and data processing, I'm going to slice up the application into these layers. Layers are good, but if we do that just based on these sort of functional criteria, we end up with maybe a small app that nicely factors out all of these responsibilities. And as we add features, what we're doing is we're adding on top of each of these things another sort of piece. So we're going back and, say, adding to our data processing to support our new models, or adding on our networking to support our new endpoints. And this sort of ends up creating effectively what I like to refer to as the Mount Olympus architecture. Brandon earlier was talking about singletons. These generally end up looking like singletons, and you get this very familiar dependency graph. We don't want this. I think everybody knows that. So, but we're definitely needing something else. So what sort of our process of planning out this architecture sort of revamp was to start with what we know. So, sorry, let me back up. So essentially, we wanted to break it down into modules. So the answer to not doing functional decomposition is to do modular decomposition. What's the difference? So modules are sort of high level. They're use case oriented. This is kind of like the theme that I'll be coming back to very often. Certainly the most important thing that I'll talk about today. The features or use cases, I'll kind of use those interchangeably. And the sort of library stuff, what I call platform, shared components, dependencies, we want to kind of think of those as modules. And then within the modules, I want to think about layers now. So whereas before I kind of started with the layers and thought of those as these functional things, I'm now thinking of the layers as really the presentation business logic and some sort of services within a module. So we're slicing this a little bit differently. And roles are the things we're probably most familiar with, is the thing that we name our class, a view, controller, that kind of thing. They're units of single responsibility within a layer within a module. Cool? These are just kind of my working definitions. I'm sure people think of these things in different ways. And then lastly, the dependencies, collaboration between these roles. So we're going to talk about the various ways we can mix and match these things. Great. So now I can get to what we know, MVC. So I definitely don't want to start this talk by saying MVC is bad. We don't do, MVC. Actually, MVC, if you look at it as what it is intended to be, is a UI architecture or like a control architecture, kind of referring to an individual component, and the idea that we can separate the sort of the domain. What I'm calling the domain is this business logic, what we refer to as kind of the model, which I'll talk about at length, and then the presentation, which is what we're mostly very familiar with, obviously view controllers. But this does have a couple of sort of limitations because it's not an application architecture. When used to model an application, certainly runs into problems, and the most common one is the massive view controller. But I would argue that there's a different problem here that's maybe a little bit more important, which I haven't heard a lot of people talk about, which is really the model in MVC is kind of undefined. I would say that if I'm interested in the domain architecture and I see this diagram, it's really not telling me anything about the model. All it's telling me is I have a model, and I don't know if I'm referring to a domain object, like a single thing. Is it a collection of objects? Is it the object plus all the machinery around it that makes things happen? I don't know. So I think that's an important question. Again, we'll get back to that. And so obviously, people were looking for improvements here, and one of those was the idea of an MVVM view model. So we add a view model, and we kind of extract a lot of the sort of presentation logic into something that's more testable, decoupled from a view controller, has all these nice benefits, and it really helps. View models are great, and they essentially further separating concerns. Maybe our view controller has one less responsibility. It absolutely is going to help with massive view controller. It might also help with sort of the undefined model problem, in that now we essentially have this view model sitting between the view controller view, which we'll commonly refer to as a view if we're doing MVVM, and now the model. So actually, if you look at the pattern, it's identical to MVC in the sense that the view model is still sitting between a view and a model, or the model, and this actually introduces a little bit of ambiguity now. I no longer am sure what is my domain code and what is my presentation code. So this kind of puts something in between, which is also useful, but possibly blurs the line a little bit between the layers, which we're also interested in preserving. But MVC is really great, and I'll talk about it some more. What's interesting, if you look at clean architecture, the view model is a really small piece. It's the output of a presenter. A presenter is the thing that now is concerned with updating the view. The view model flows out of a presenter. And then as input flows in from the view to a controller, it generates the request model in an interactor. The interactor does the sort of work of manipulating the entities in your model. It's working with this new thing called a gateway. This is a great concept we can inject behind some protocol, something that represents an external dependency. It could be a database, it could be the network, anything that I would consider I/O kind of would sit behind a gateway, and we can, and we do also talk about these as services, and I'll talk about that a little bit more. Clean really starts to answer the question of what does the model look like? This interactor thing, it's actually referred to as a use case interactor, and starts to really put attention on the behavior that's happening. How is the data changing as the user interacts? So we're really concerned with data interaction. And this is really great. If you do clean, there's a cleanswift.org site. This same pattern is referred to as a VIP also. And it's a pretty powerful pattern. People that do it really love it. It does a couple things that are a little bit risky, and I'll talk about that a little bit more later. Again, I'm leading up to this thing, but I'll say for now that when you create a module in VIP, you create a scene, and the scene gives you the view controller, the interactor, and the presenter, and it's effectively creating a unit of code that's still based on a view. So everything we've seen up until now is a view-based, I would say, a view-based architecture. It's looking at the screen and then kind of hanging everything off of that screen. This is something that is a little bit concerning, and I'll get to that. So clean is awesome. Everything has protocols in between. This is very well abstracted, very testable. This is something we really drew a lot of inspiration from and appreciate. Okay, so there's a version of Clean, sort of something that was derived from Clean, which is Viper. And Viper's interesting. It's moving the presenter kind of to the control position, sort of the driver, if you will, and it's still more or less thinking about a particular view. And if there's navigation, it's introducing the concept of a wireframe or a router, and this is kind of making the new view controllers, presenting them. If you had a multi-step flow, this might be doing the individual steps and transitioning between steps. And there may be some cases where, as you move from screen to screen, you're going to be using a series of different interactors. This is not a requirement, but I think it's a very common structure. Something that I noticed that I really was interested in was the idea of this use case sort of consolidation, or the coherence of this use case. So can I go in my code and find the implementation for one use case, and can it look like a script that I can read? Like, what is the story of this particular use case? And we ran into the same issue just thinking about Viper, that story is not very well represented anywhere in the code. It's a problem with a lot of object-oriented systems, is that you have to kind of piece together the story from all over the code base. So I think a big goal in a lot of modern architectures is to try to pull these together. And I'm just curious, show of hands, who's heard of DCI? Cool, at least 1, 2, 3. It's this kind of a small number. I expected it not to be a large number. This is a very, very interesting piece of work. The first thing about it I think I should mention is that while we as a community have been sort of like frowning upon MVC, the creator of MVC has sort of answered our concerns with DCI, right? DCI is the complement to MVC. It's the model side of the sort of MVC architecture equation. This models behaviors in the system. And the context, or use case context, is the primary sort of container for system behavior. It actually executes a use case. So anything that's going to happen in the application is going to happen in a context. Now, that actually sounds really good. Just talking about it, it makes a lot of sense. If I'm doing something, I'm sort of in this context, and there might be state associated with this thing that I'm doing. I think of it as a process, almost, that's running. I could think of an application as a collection of these running processes, and a context is a really beautiful representation for that. It's also on the domain side. So because it's over there, we can actually write our context so that they represent all of the sort of internal system behavior, data transformation that takes place within the app, and then I can reuse this in different apps or in different views. or I can have a many-to-many relationship between my views and these contexts that happen to be around. So these wouldn't be singletons. These would be instances that we inject in different ways. So that's more of a detail. This is more high level, but effectively, DCI answers the question of how do we solve massive view controller, and that answer was provided by the creator of MVC. I think that's worth a second look at MVC also. The other thing I want to mention about DCI, which I really think is important, and the one thing I can say definitively is that Swift is the best language in existence to implement DCI. And the reason is these object roles over here, what these are all the methods to the data that we're considering to be basically dumb. I didn't mention this earlier, but from clean onward, and you could argue in MVVM it's the same, that the data is really, there's no behavior in data. So anything we've learned about structs, immutable data types, they're basically just collections of data. It's very simple. They're inert. You don't sort of, they don't behave, right? This is a great thing. So all of these examples are building on that idea. DCI is a little interesting in that it actually does keep sort of a register of methods, but separate from the data, and attaches it to the data in a context. Now this is kind of cool. If I have a user in one context, it might have a certain behavior associated with it, like let's say I'm in Tinder and I see a user and it's a recommendation. Maybe in this context, the user wants to show the photos or whatever. But in a chat context, maybe the user wants to send me a message. Well, if I'm working with that user object in a recommendation context, I'm not going to necessarily see the send message on a user, for example. I'm not saying we should have these methods on users, but in DCI, we're able to utilize object roles and attach methods to objects. Well, that sounds a lot like protocols and protocol extensions. And in fact, we want to make heavy use of these protocols and protocol extensions to implement what is the interaction in DCI is the object roles. And that's how we build the relationships between data and other data, and how we sort of how we express it in a context. So again, this is all sounding very sort of, for me, very natural language. As I talk about a use case, I'm talking about the roles, I'm talking about data, I'm putting this stuff together in a context, and it flows. Like when I'm reading the code, I'm understanding what's going on. The #1 mission of DCI is to map the programmer's mental model into the system the way MVC mapped the user's mental model in the system, and to kind of converge the user and programmer mental models into one sort of unified language. This is also a very common theme in domain-driven design. Very, very useful and powerful sort of technique. So you can sort of mix these architectures. We love DCI, but we had a problem actually. The contexts would invariably, because they're representing use cases, and these use cases are complex, they have many steps, and many of these involve presentation. Suddenly we're making effort, like before we're trying to keep our model out of our view controllers. Now we're actually trying to keep our UI out of our context. And this was actually pretty awkward. So we had to kind of make we had to adapt a bit to make this work in a way that I think is very sort of natural on iOS. So for example, I might still like to have a view model. And there's nothing to say that I can't use MVVM with DCI, because if MVC is compatible with DCI, and MVVM is very similar to MVC, but allowing me to write something that I can sort of test in a view model, maybe this view model isn't going to be handling all of our user input, which surely is being sort of routed to a context, but maybe it is still doing the sort of data binding to the view and implementing observation, these kinds of things. So it's still really useful. We don't have to use them, but they're available to us. It's another tool. All of these are valid roles in the system. I want to mention one other thing, which is the service again. You saw it as a gateway and clean. The service is little things. They're tiny. This would be like the HTTP service or an API service. It wouldn't know any of your application at all, right? So it would be really a couple of methods that just implement a protocol that you can inject And so we're injecting only this minimum amount of external dependency, and we're not cluttering these things with your domain objects, your endpoints, your APIs. These would live inside of a context, but that gets actually a little bit messy. That's a lot of code to put in there, right? You're gonna say, wait a minute, I had an API thing, I had a data thing. We were talking about those functional roles earlier, and so you want me to stuff all this into a context? This thing's gonna be our new massive object, right? Instead of one of them, we'll have one per use case, but that's not gonna necessarily help enough. And so we combined a few more of these ideas. So everything I've talked about is great in different ways, and they each have some problem. Some of them minor, some of them a little less minor. We really wanted to have an important part of our architecture in the domain that I could move around, that I could reuse, that I can think about and reason about, and these contexts were great. On the view side, we had a lot of options, but they were a little bit I think there's one more problem here. The code that wants to be in the context to model a use case is code that really needs to also exist, and it needs to be first class. In fact, I think it's actually above a context. And so this is what we're doing. So we call it Discover, and we take what we've talked about, everything we talked about, and we introduce a flow. So flows also, and I didn't have a slide for this, but you've probably heard of coordinators. You've probably heard of a flow controller. You've heard of wireframes in Viper, and you probably know what a presenter does. If you put those things together, you basically get a flow. Now, when I think about a flow, I'm thinking about screenshots handed down with, from a product manager or a designer. It's a sequence again, but some of these things are on one screen. Some of them involve navigation to other screens. And if these are actually part of a single use case, I actually want to put them together in a flow. Flows are the single sort of control point for our application. So we still have view models. If we need them, we can use an observer on a context. If we want to do reactive stuff, if we want to use RX, whatever, this is totally framework independent. There is no GitHub repository, download this SDK. It's not like that. This is just how we structure some code. And then internally, we can choose our dependencies, and we can choose maybe our view architecture might be a little different. But the two important aspects of this is that we take our use case behavior, and we put it in a context, and then we take our user experience, and we put it in a flow. It's that simple. If you do those two things, I would argue you're doing Discover. Now, you can call it anything. That was actually something that one of our writers thought of just because it fit a bunch of the roles. So I thought it was kind of cool. The other thing I didn't mention is interactors in this world. So the interactors pull out of a context the stuff that I was talking about earlier, which is like a lot of minutia. And it's also extremely sort of transactional. This is how you should write an interactor. There's a request, there's a response. It's stateless. If you're doing functional programming, this is a great place to sort of concentrate all of your transactions and transformations. If you're using some sort of persistence library like Realm or Core Data, this is a great place to kind of concentrate all of this kind of minutia, right? So I kind of think of context as these meta objects, and I think of interactors as these meta methods, right? They're actually like objects that perform work, but they're units of work. And who's heard the talks? A lot of people talked about. I think Andy is going to talk later. He's mentioned on many occasions the functional core and imperative shell. Hands. This is a very, very, very interesting, powerful pattern, and I think context and interactors implement this very beautifully. The context would hold some state. It could just be data. We're doing transformations on interactors. We're holding that result in a context, and we can use, again, any patterns that we like to achieve this, from object-oriented patterns to functional patterns. It's wide open to interpretation. So one thing is, this is just one module. It's just one use case. So this only exists in the context of an application. And there's an interesting thing also, which is that application itself was kind of one of my modules. If you remember, there's that sort of app module, and this is one use case module. So actually, the use case presentation, use case domain are part of that same module. And there's a funny thing, which is the service is actually part of the application domain also. So if I'm putting together the application, all those high-level sort of, or I should say low-level application-independent dependencies are inside of these services. So I think of this as a matrix. And this is kind of what you get when you extract it out to the app level. So this is just one use case on the bottom. There's a flow, maybe there's a view model, there's a view, you've got a context interactor, maybe it's taking, I should fill in the dependencies. Yeah, so now you can kind of see how we would build this. And this is really interesting because we would always think of presentation and domain, and then we might think about an application and a use case, but if you sort of primarily slice on either one of these, it's actually not quite right. They're a little bit orthogonal. There's actually an application presentation layer, there's an application domain layer. There's a use case presentation, there's a use case domain. So this is actually like just a very simple sort of map for me to think about where does this code belong? Is it part of use case? Is it part of presentation? And I can think of it along these two sort of independent axes. I think this was a really helpful tool. And if you notice on the top, I've added this sort of extra layer, which is a session container, which could be like your navigation container, a tab something. This is when the user logs in and they're done logging in, what they would get, right? So that would kind of host the application UI. A session flow might decide whether to provide a login screen or the application, for example, and you might have a session context that deals with a lot of your auth and keeps track of your tokens and that kind of thing. So again, it's just giving us a very clean way to break apart and organize all of these things that we kind of constitute the application. So that's the pattern. So I'm going to go really quickly through the roles because I'm basically out of time. The data structures, you know, these are tree, value semantics, inputs, outputs, and state. Interactors are the functional core, state transformations. Services are lightweight. They don't know about your app, but they might be networking, frameworks, or external dependencies. We can inject these as protocols. The context is the imperative shell, state or behaviors relating to one use case. Observers emit data. Basically, they can be used anywhere, but they're really helpful for us to build a unidirectional data flow that I can mutate the data, and the view can just update as it's changed. So that kind of decouples the reading and the writing when interacting with the context. The view, anything you like. So the view can be MVC, it can be MVVM, it could be your functional reactive UI abstraction, whatever makes you happy. I think it's really important on a team to have a view architecture that everyone likes. Maybe you're in a team where everyone's all in on RX, and that's what you should be using there. If you're on a team where you want to do a new thing, that's what you want to do. And then if you're on a mixed team, maybe you want to use the lowest common denominator. You could actually do MVC, and it works really well. Entities, I won't really get into, but if you're using sort of like an external, like a realm or a core data, this is kind of where you keep your object graph. And then the flow, which is actually the most important thing, should probably be first, but it would destroy the acronym. High-level UX presentation, navigation, modals, deep linking. That's a lot for a flow. So what are the benefits here? It's very modular. It's composed around use cases and behaviors rather than presentation. It implements a functional core imperative shell. This is a very powerful pattern. It's very testable. I've found we can unit test almost everything. Some of the things we'll integration test if we don't want to create extra protocols. And I think there is such a thing as protocol fatigue. Although I love protocols, I do think they should be used in the right places. That works really well in the services. It works really well kind of at the major architectural boundaries, but you don't need them everywhere internally. So we do a lot of integration testing, but these are synchronous tests and they're very easy to write. I would call them almost unit tests for just a larger unit. Therefore, integration tests. Observers can be done in pure Swift. It could be done with an external framework. You don't have to use observers. There's a standard flow that would just eliminate that layer. Bring your own view architecture, mix and match. And then flows. Flows are really the key to this. They tell the complete story. they tell it kind of one method at a time. So you can imagine like starting a view controller and with a closure instead of a delegate, getting back a completion event, and firing an analytics event. Like actually, we can implement all of our analytics in a single flow. This is very, very powerful. I think there are other examples of this, like coordinators, flow controllers. Viper does a pretty good job in the presenter to achieve this kind of similar thing. So we're just kind of branding it as a flow, and people kind of like how that sounds. And routing, navigation, deep linking, you achieve via composition of flows. So there's going to be some sort of enumeration and a tree of the things that a user can do, where they are, and when you want to do some sort of state preservation, we're going to sort of capture that state, and then the app flow can build, the session flow can build the UI flows as needed to like sort of get you to the right place. So this last one alone, I think, is a complete talk. I'd love to elaborate on that. So we'll be hopefully sharing on our tech blog some of these, some of the implementation for this. And that's what I got for you today. Thank you very much.